everyone. In this video, we're going to continue our notes on section 1.7 on limits and continuity. So let's first look at this box on the top of our page 36. So here we have a list of continuous functions. So far in your math career, or maybe you've heard this term before, but there are various families of functions. So some of those families include things like polynomials. So functions that look like x squared plus 2 or x to the 5th plus x to the 2nd plus 3x. These types of functions are called polynomials. It's a whole family of functions, and they are all continuous. So there are several ways to show that they are all continuous. That's left to a different math class that maybe you'll meet in sometime in your future. But in this class, we're just going to go with assuming that is the case. If you look at a graph of any of these functions, polynomials, you'll see that they are in fact continuous. We also have that rational functions are continuous on their domain. So that means like the function that we saw in example 1, written as x squared minus 1 over x plus 1. This is continuous on its domain. Note that x equals -1 is not in the domain of this function. We also have root and power functions. So functions like x to the 7, it's a power function, x squared is a power function, and root functions like square root of x, cubed root of x squared plus 1, things like that are all root and power functions. Constant multiples of continuous functions. So if we had a continuous function from up above, so suppose f is continuous, then a times f is also continuous. Or if you want to see a number, 7 times f of x is continuous. And then combinations of continuous functions. So sums, differences, products, quotients, and compositions. So if f and g are both continuous, then the sum is continuous, or the composition f of g is also continuous. So you do not need to memorize all of these families of continuous functions, but it's good to recognize them. And it's also important to see that there are many families of functions that are continuous. So with that in mind, let's take a look at example 2. Example 2, we're given the function f of x equals root 2x plus 1. And we're asked, is this function continuous at x equals 4? Please explain. So one way to think about this is considering f of x as a composition of functions. So the outside function is a root function, square root, while the inside function is just a linear polynomial, 2x plus 1. So one justification here, oops, keep moving around here. So one solution is that, or the solution rather, is that yes, f of x is continuous at x equals 4. One explanation is that f of x is a composition of the root function, which is square root of the inside. And so it's a composition of the root function, square root of x, and the linear or polynomial function, 2x plus 1. Each of these functions are continuous, so their composition is also continuous. Another way to justify this is to check the conditions for continuity. So what would we need to check? We need to check f of 4 exists And yep, we can just plug that into our rule, 2x plus 1 square root. So 2 times 4 plus 1 should be the square root of 8 plus 1, which is just the square root of 9, which is 3. And then we also need to check that the limit exists. The limit as x goes to 4 of root 2x plus 1. Well, there's no issues plugging in x equals 4 here. So that limit is equal to the square root of 9, which is 3. And then lastly, we see that the limit is equal to the function output. So star is equal to star. So check, that third condition is met.